But architectural steps read
You can't hear me?
Let me just get off the phone. Okay, now I can hear you.
Can you hear me now? Okay. All right. Sorry about that. So I'll start. As I was saying, I'm Maduleka. You can call me Nancy. I'm going to take you through grade 7 maths. We're starting with term 2 work. And the first topic that you do is common fractions. Okay, so at the end of the lesson, let's look at the success criteria. Okay, before we do that, so we're going to look at ordering fractions, comparing fractions, and also we're going to look at simplifying fractions. And then the success criteria, by the end of the lesson, you should be able to know what a common fraction is. And you should also know the different types of fractions. We're going to look at that. And then you should also be able to compare and order fractions with the same denominations. We have been doing that since grade 4. And then you should also be able to compare fractions with different denominators. And the last thing that you're going to do today will be simplifying fractions. All right, and then what is a common fraction? I'm sure. Okay, so a common fraction, we're starting with a fraction. A fraction is a portion of a wall that has been divided into equal parts. And then a common fraction is written as, if you can see here, as A over B. But then this over B on a fraction now, as you're in grade 7, you must remember that it acts as a division line. So we can say A divided by B is also going to help you when we go to decimal fractions. So a common fraction is written as A over B, and the number A represents a whole number called the numerator, or it tells us, if say it's a pizza, it will tell us John ate 3 over whatever of a pizza. And then B represents a whole number called the denominator. So in a fraction, we have a numerator, and we have a denominator. And then we have basically 3 different types of fractions that you're going to look at in grade 7. So the first one is a proper fraction. So this is where the numerator of the fraction is less than the denominator, for example, 2/5. And then the next one, okay, no volume. Okay, let me just deal with the volume part. All right. Okay. All right. So as I was saying,
Yeah, keep it on with the audio on so I can handle it handy.
so as I was saying, the proper fraction, this is where the numerator of the fraction is less than the denominator. For example, we have 2/5. So if we look at the numerator there, it's 2 and the denominator is 5. And then say we're talking about a pizza, the pizza will be divided into 5 equal parts. And then if John decides to take 2, then we represent it as 2/5. And then the next one, we have an improper fraction. And then this is where the numerator of a fraction is bigger than the denominator. For example, 8/6. And then we have a mixed number. So a mixed number is a number consisting of a whole number and a fraction. For example, 5 wholes and 2/5. Sometimes we write an improper fraction as a mixed number. For example, 8/6 can be written as 1 and 2/6. And then a mixed fraction, a mixed number can also be written as an improper fraction. So on our next lesson, we're going to be checking how we convert the mixed number to an improper fraction and the improper fraction to a mixed number. So now back to so now we are on comparing fractions. What prior knowledge should you have? So now you're in grade 7. In intermediate phase, we started doing fractions in grade 4, and then we looked at the numerator and the denominator. So now you can easily identify the numerator and the denominator of a fraction. If someone have to come to you and say, write a fraction 1/2, and they say which one is the numerator, in grade 7, you should be able to know that the numerator is the top number and the denominator is the bottom number. Also, you know that if the numerator and the denominator are the same, we call it a whole number. So if we have, say, 2/2, it means it's a whole number. If it's 3/3, it's a whole number. If it's 6/6, it's a whole number. So a whole number is a full number or a complete number. If we have to shade, you are given, say, a circle or a rectangle, and you have to shade. For a whole number, you are going to shade everything. So that is how we represent a whole number in a diagram. And then by now, you should also know the meaning of the symbols greater than, less than, and equals. So we have been doing comparing not only of fractions, but we have also compared numbers. When we do whole numbers, we compare, and these symbols, you should be able to use them effectively. Do not use them, because most of the times, learners confuse the greater than and the lesser than. Just going through the symbols, always we see the bigger number gets the mouth of the fraction, and then the smaller number gets the elbow point. And then equals obviously means that the fractions are equal. And then you also know the rules of fractions. say if we're adding fractions, you know that we have to add the numerator and not the denominator. So going to rules of comparing fractions, they're quite simple. If the denominators are the same, you have to look at which fraction has the biggest numerator. So I mentioned that we have a numerator and a denominator, numerator being the top number and denominator being the bottom number. So if the denominators, meaning that if the bottom numbers are the same, which is the denominator, we just have to look at the numerator at the top number, and then we see which one is bigger and which one is smaller. Okay, so now looking at the examples of comparing fractions, I really hope that you guys have a pen and a paper, because math is a practical subject. You cannot just listen. If you see that I've written some sums, can you please grab a paper and a pen, write them before I say the answer, also see if you are able to do it. So I hope that people have some, okay, so I see there's people that can hear, all right. So now looking at the fractions, I have given you 3/10, which we say it properly is 3/10, and then we have 1/10, which is 1/10, and then we have 9/10, which is 9/10, and then we have 5/10, which is 5/10. Very important, always you have to read what the instruction says. So at the bottom of those fractions, I have said we must order. Okay, we must order those fractions from biggest to smallest. Now that you're in grade 7, your teacher might not even use biggest to smallest, but they can use ascending or descending. So that is another thing that you have to know. Descending, meaning that is from biggest to smallest, and then from smallest to biggest, and then ascending, meaning is from smallest to biggest. So you have to know those terms. So if we look at those fractions, already you can see which fraction is biggest. We're just going to check the numerators. As we said that if the denominators are the same, it means we're comparing things of the same quantity. So the denominators are 10, 10, 10, so it's the same. So the biggest fraction will then be 9/10. Now, if we take it practically, because math is about practical, it's about practical things that we do every day. So if, say, your parents buy you a pizza and then it's divided into 10 equal parts, and then you decide to take 9/10, someone decides to take of the same size of the pizza 5/10, and someone takes 3/10, and someone takes 1/10. So obviously the one with 9/10 would have the bigger part, followed by 5/10, followed by 3/10, and then the last one is 1/10. So it is very easy to compare fractions if they have the same. It's very easy to compare fractions if they have the same denominator. Now, not that the denominators are the same, so we just look at the numerators. So then we can see the answer there at the bottom. But wait, what if the denominators are not the same, but the numerator is 1? So this is now another 10 of fractions. So you can be given, remember when you're writing, whether it's an assessment, you can be given just the fractions with the same denominator, or they can put a 10 on it and then give you the denominators being different, and then the numerators having 1. So now most of the learners, which is a misconception, most of the learners can then say, okay, most of the learners can say that the biggest fraction is 1/10, which is, yeah, you are right, it's incorrect. So we don't look at the denominators if we are given different denominators. Let's look at this. Okay, so now let's think of a cake. I've given you a nice picture of a cake there. So if we have 4 same-sized cakes, like the one above, and then we cut one cake into 2 equal pieces, and then we cut the other in 3 equal pieces, Then we cut the other in 5 equal pieces, and the last one we cut in 10 equal pieces. Which cake will have the bigger slice? So I want you to imagine this same size cake, and there are 4. The first one, we just cut it into 2, and the second one, we cut it into 3. The third one, we cut it into 5, and then the last one, we cut into 10. Who is going to get a bigger piece, or which cake is going to have bigger pieces? Okay. One that is cut in 2 has bigger pieces. You are right. So if the denominators, if all the fractions that you are comparing have a numerator of 1, then the smaller the denominator, the bigger the fraction. This only applies if your numerator is 1, if your numerators are 1 and the denominators are different.
I don't understand.
1 over 2, which is the first fraction that we have after 1 over 1, becomes the biggest fraction. And then 1 over 3 is the one that follows. 1 over 4, 1 over 5, 1 over 6, 1 over 7. So if we are comparing here, we are comparing 1 over 6 and 1 over 8. Can you see that? And then someone can say 1 over 8 is the bigger fraction because they are looking at the denominator, which is not the case. Because go back to the example that I gave you when I said the smaller the denominator, the bigger the fraction. So go back to that cake, and then one is cut into 8 and the other is cut into 6. Which cake is going to have bigger slices? So of course 1 over 6 is bigger than 1 over 8. So that is the sign that you use. As I was explaining, that if you're still confusing the sign, this is the bigger fraction, meaning that this fraction is the one that gets the mouth of the sign, and then this small one gets the elbow part of the sign. And then the second example that I have is 1/3 compared to 1 over 100. Now I know maybe you are now visualizing it. If I have a cake that is now same size, one is divided into 3 huge pieces, and then we take the same size of cake, we divide into 100. So imagine how small the pieces are going to be. So yes, you are right if you thought it. 1 over 100 is smaller than 1 over 3, which is 1/3. So now remember, if you are given fractions and then they have a numerator of 1, but they have different denominators, the smaller the denominator, the bigger the fraction. And then here we have another sum. It says order from ascending to descending order. So ascending, if you're also confused about those terms, something that ascends is something that goes from lower going up. Think of an aeroplane. When an aeroplane takes off, what do we say? We say that it ascends, right? So it means ascending is from smallest to biggest. And then descending, how do you descend? You have to descend if you are up. So descending means from biggest to smallest. So let's go back to the question. It says order from ascending to descending, meaning that you have to order from smallest to biggest. And you can also know how ascending, what ascending means. A is the first letter. So we can say A is 1 because it's the first letter of the alphabet. And then D is the 4th letter. So A being the first letter, being the smallest, it means ascending is from smallest to biggest. And then descending, because D is the 4th letter, then it's from biggest to smallest. I hope you do not forget that. So looking at those fractions, we have 1 over 20 or a 20th, we have a half, and then we have 1 over 45, and then we have 1 over 5, and then we have 1 over 10. So if you had a pen, or if you have a pen with you, I'm sure you have written from smallest, the smallest fraction there is 1 over 45, followed by 1 over 20, followed by 1 over 10, followed by 1 over 5, and the last one is a half. So that is how we compare fractions, or we order fractions that have the numerator as 1, but the denominators are different. So we have looked at two things basically. The first one, we looked at fractions that have the same denominator but different numerators, and I said that if the denominator is the same and the numerators are different, you have to look at the numerator to determine which fraction is bigger. And then the second instance is when the numerators are the same, which is if the numerator is 1 and then the denominators are different, and I said the bigger the denominator, the smaller the number, or the smaller the denominator, the bigger the number. Okay, so I'm going to move on. Okay, so now we're going to look at ordering and comparing fractions with different denominators and numerators. So now we're going to put a twist into it because the level is changing. Remember, in grade 4, you started doing comparing fractions 1 over 10 and 2 over 10. Then you know, obviously 2 over 10 is bigger. But now you guys are in senior phase. So we are going to now look at fractions with different denominators and different numerators. Okay, so there is a rule there. What rule number 1 says, never compare fractions if the denominators are different. So meaning that you cannot compare 2 over 7 and 1 over 3. And then you say, oh, 2 over 7 is bigger because I see that the 7 is bigger. Or maybe you say 1 over 3 is bigger because I don't know what your reason will be. So you have to make the denominators to be the same. Only then can you compare. I love telling my learners that you cannot compare a donkey and a cow. For you to call, if someone goes to a farm, the farmer has goats and the farmer has sheep and they have donkeys and they have cows. And then someone asks, how many cows do you have? The farmer cannot add all the cows and the donkeys together and then say, I have, say, 50 cows, including the donkeys. So we have to make things the same. So we have to make the denominators the same. That is the first rule. Never make a mistake of comparing fractions. If the numerators and denominators are different, don't make the mistakes of the mistake of comparing the fractions without changing the denominator. So, for example, we have 2/7 and 1/3. And then if we look closely at the sum above, we have different denominators and we have different numerators. So then how do we see which one is bigger without using the fraction rule, of course? Okay, so now you guys are in senior phase. You are not going to use a fraction rule. In a test, you're not even going to be using a fraction rule. Why? Because you are moving from, okay, yes, Gerard, I see the LCD, they're wonderful. We cannot move from, okay. You're not allowed to use the fractional in grade 7. You have to move from concrete to abstract. What does that mean? In grade 4, every time you do fractions, you're given a fractional and you can easily use a ruler and you can see, oh, okay, I see now a third is smaller than a half. Now you are in abstract, so you have to use, as Gerard said, the LCD, which is the lowest common denominator. Thank you. So back to the rule, we have to make the denominator the same, but how do we do that? There are several strategies of doing this. We're just going to look at a few. Remember, with maths, there's so many ways of killing a cat. I'm not saying you should use only these strategies. If you have more and you arrive to the same answer, by all means, explore them and use them. So I just listed 3 strategies, and one of them is the one that Harold said. So most of you might know 1 or 2 methods. It's fine as long as you understand it. You have to use it. So strategy 1, this one I like the best. Okay, I like all of them the best. Okay, let me not say which one I like the best. So strategy 1 is whereby you cross multiply the denominators. Cross multiply the denominators, and then your fractions are so many rules. Remember, whatever that you do on the denominator, you have to do it on the numerator. So we are comparing 2/7 and 1/3. So I say the first strategy that you can use if you are lazy like me, you take this denominator, the 3, you multiply the opposite fraction, and whatever that you do here, you have to do on top. And then you do the same thing to the opposite fraction. You take this denominator, which is 7, and then you multiply the opposite fraction. So how did I do that? I said 7 multiplied by 3, which will give me there, if you look at the bottom, you can see it's 21. And then you say 2 multiplied by 3, because it's a fraction, you cannot separate. I always tell my learners, it's a husband and a wife, and you cannot separate that. That's another way of remembering it. So there we see, I said 2 times 3, I got a 7, and then I said 7 times 3, and I got a 21. 2 times 3, I got a 6, sorry. And then we move on to the next one. 1 times 7, now I use this denominator, the 7. I'm now multiplying the opposite fraction. And then I say 1 times 7, and then I'm going to get 7. And then you say 3 times 7, and then you're going to get 21. Now, what did you just do here? So we see here, the denominator is 21 and is 21. So we managed to make the denominators the same. Can we then now compare? Yes, we can. Why? Because the denominators are the same. Now, which one is bigger? So 2/7 becomes 6/21, and then 1/3 becomes 7/21, and then obviously the bigger one is 7/21. That is strategy number 1. And then we move on to strategy number 2. We have to find the lowest common denominator of 7 and 3. This one, your multiples needs to be on top, on point. Because if you miss one multiple, you're going to have a false denominator. So make sure that your multiples are on point. In grade 7, I'm sure by now you can sing multiples, you can dance multiples, if I can put it like that. So strategy number 2, you find the lowest common denominator of 7 and 3. So you list the multiples of 3. I listed them here. You can see it's 3, 6, 9, 12, 15, 18, 21, 24. Okay, I just moved on to 24, just in case you get carried away in listing your multiples. And then the multiples of 7 is 7, 14, 21. So the lowest common multiple here is 21. What does lowest common multiple mean? Remember, we did multiples, and you did the HCF and the LCM when you were in term 1. Actually, you did that in term 1. So by now you are familiar with how we can find the LCM. So now that you know that the lowest common multiple is 21, then we go back to the fractions. We still use the same examples that we had, 2/7 and 1/3. Then we take 21 and then we make it our denominator, right? So we say 21 and then we divide 21 by the first fraction's denominator. So we say 21 divided by 7. 21 divided by 7, we get 3. Okay, let me do my cursor here. So the original fraction that we had was 2/7. So this is 2/7. And then we have found the lowest common multiple, and then we say it is 21. Then we say 21 divided by 7. So 21 divided by 7 gives us 3. In case you were wondering where this 3 is coming from, this 3 is coming from 21 divided by 7. Can you see that? And then this was the original numerator, 2. Then we say 2 multiplied by 3, and then we get 6. This is the first 2/7. Eh? And then let's move on to 1/3. Still take the lowest common multiple, which is 21. And then our denominator was 3. So I'm going to say 21 divided by 3, and I get 7. This 7. Eh? And then our numerator was 1. So then I say 1 multiplied by 7 equals to 7. And then if you can see here on red, I wrote, then it's 6. And then we use this common multiple as our denominator. It's 6/21. And then the 7, the answer that you got is 7/21. So then we can now compare the fractions. At the bottom here, I just explained it more. 21 divided by 7 gives us 3. Then 3 multiplied by 2 gives us 6. That is the first fraction. And then 21 divided by 3 equals to 7. And then 7 multiplied by 1 equals to 7. And then we use the common multiple, the LCM. We use it as the denominator. So we end up having 6/21 and 7/21. Then we can compare. We go back to the symbols, and then you put the appropriate symbol. I hope you understand this strategy. And then now we move on to the third strategy. Okay, so every time you have to look at what kind of fractions are you given to see which appropriate strategy should you implement. So in this case, this one is making one denominator a multiple of the other. For example, if you're given 2/4 and 1/2, and then 2 is a multiple of 4. It's a factor of 4, sorry. 2 is a factor of 4. So what we have to do, we just have to make sure we make these denominators the same. So if you're given numbers that you can see, okay, this one, if I multiply 2 by 2, I get 4. So I'll have a 4 here and I'll have a 4 there. So I can, and remembering, not forgetting that whatever that you do at the bottom, you have to do at the top, or whatever that you do on the numerator, you have to do on the denominator. So if I multiply this denominator by 2, I have to do the same thing on the numerator. Okay, I'm going to repeat that. If you are comparing fractions and you can see that one is a multiple of the other, so you only just have to change one part of the fraction. For example, I gave you 2/4 and I gave you 1/2. So what you do, we just need to, because I know, or you know, that if you say 2 times 2, you get 4. Then you just easily say 2 times 2 to get 4. And whatever that you do at the bottom, you have to do at the top. So you multiply the numerator by 2 and multiply the denominator by 2. So at the end, you're going to have 2/4, comparing it to 2/4. So they are equal. So you can do more of these examples at home. Okay. Which brings us to the next activity of comparing fractions. All right. So here I just grabbed some worksheet. So we're going to quickly go through the worksheet together so that we have time to do simplifying fractions. Here, the first one, number A, we are comparing 4/6 and 12/12. Immediately in your mind, if you see 12/12, you have to know that it's a whole. Remember, a whole number? So 12/12 is a whole. You don't necessarily need to go through the working out to find the answer, but then should you maybe not recognize that it's a whole, then you can see here 6 and 12 there is some relation there. If I multiply my 6 by 2, I'm going to get a 12, which gives me the same denominator. So 6 multiplied by 2, I get 12. And then remember, I said whatever that you do on the denominator, you have to do on the numerator. So the denominator, we multiplied it by 2. The numerator, we have to multiply by 2. So 6 times 2 gives us 12. And then 4 times 2 gives us 8. We do not have to change this one because already the denominator is 12. So then we can compare. As you can see here, this one is the bigger one, gets the mouth, and then the smaller one gets the elbow. And then we go to number B.
Hello.
Number B is very easy. You can see it's the same fraction. 6/9 and 6/9, they are equal. So you just put the equal sign. And then same applies to number 1C. 10/10 and 6/6. Also, it's whole numbers, so they are equal. 2A, we have 12/12, which is a whole, and then 10/11 is not a whole, because if it was a whole, it was supposed to be 11/11. So 10/11 is less than 11/11, which is a whole number. So then the smallest or the biggest one is 12/12, and then your sign is going to face 12/12. And then 2B, we have the same whole number. So this is, I'm giving you this activity so that you can reactivate that brain or that knowledge that you had, the prior knowledge. I'm trying to connect to what you learned in grade 6, because it's been like term 3, term 4, term 1 that you didn't do fractions. So I'm trying to activate your brain. So 7/7 is a whole, 8/8 is a whole. So that is equal. And then 2C, okay, I did that one. 2C, we have 7/11 and 9/11. Sorry. Okay, so if you remember on the first thing that we said if the denominators are the same, you simply have to look at the numerator. And which numerator is bigger? 9/11. Yes, you guessed it right. Let's move to 3A. 3A, still same denominators, which is 12. You can easily compare that one. And then 3/3, which is a whole, and 3/6. The bigger one is the whole because it's full. And then number 3C, still the same. And then number 4A. Okay, let's dwell on that one, number 4A. So we are comparing 1/11 and 1/6. Different denominators. Yes, we might be having the same numerator, but we have the different denominators. So for you, maths have to make sense. So for you to prove this, I've given you strategies. You can use a strategy. Here, I decided to use the cross multiplication strategy. So I took the denominator of this side and I multiplied this side. So I said 11 multiplied by 6, and then this side I say 6 multiplied by 11. Whatever that you do on the numerator, we have to do on the denominator. So 1 times 6 gives us 6, 11 times 6 gives us 66, and then same applies to that side. 1 times 6 gives us 6, and 1 times 11 gives us 11, and 6 times 6 gives us 66. So we can see which denominator is, or which fraction is bigger. I'm going to move on to the last one, which is simplifying fractions. Now, once you have mastered making the denominators the same, simplifying fractions becomes easy. Let's go through the rules of simplifying fractions. 1, we can only divide when we simplify fractions. Simplify means it was bigger and now we're making it smaller. So to simplify, it means you have to make it smaller. So we can only divide, you cannot subtract. We can only divide. 2, what we do on the denominator, we also have to do on the numerator. I've said that several times during the lesson. 3, the number you choose to divide with must be a factor of both numbers. If it leaves a remainder on either the numerator or the denominator, then you do not divide with it. So the number has to be a factor of both the numerator and the denominator, and you cannot have a remainder on fractions. So you cannot say 2/3 and then you decide to divide by 2, and then you divide 2 by 2, you get 1. You divide 3 by 2, you get 1 remainder 1, and you write your answer there, 1 remainder 1. No, it does not happen. So it has, the number that you divide with has to be a factor of both the numerator and the denominator. Number 4, you divide the fraction until it is not divisible. So you divide it until you cannot divide it anymore. If one of the numbers is a prime number, it is already in a simplified form. You did prime numbers in term 1, in grade 6 you did prime numbers. So your prime numbers, those are the numbers that can only be divisible by 1 and itself. So if you are dividing and you see that your answer is either 1, or 1 is not a prime number, sorry, 3, 2, 3, 5, 7, 11, 13, then you leave it. It's already in a simplified form. So now let's look at the examples that I have for you there. We have 6/12, and then you can divide these 6/12 by 6, because 6 can go into 6 and 6 can go into 12. There is nothing wrong if you first divide it by 3 to get 2/4, and then 2/4 is not in its simplest form. So you have to further divide it by 2 to get 1/2. And then 7/10, you can see that I said my answer here is equals to 7/10. Because why? 7 is a prime number. So this means that there is no number that can divide 7 besides 1 and 7. And we know that 1 does not count when we are dividing. So 7 cannot go into 10, therefore we leave it as 7/10. And then number C is 18/100 divided. So you have to find a number that goes into 18 and a number that goes into 100 and leaves no remainder. The first one, because it's even numbers, 18 is an even number, 100 is an even number. The first one that will come to your mind is to divide it by 2. And then I divided it by 2 now, and then 18 divided by 2, I get 9. 100 divided by 2, I get 50. Then now you have to check which number can go into 9 and can go into 50 and leave no remainder. You go back to your odd and even numbers. 9 is an odd number, 50 is an even number. So 2 cannot go into 9, 3 cannot go into 50, so that is in its simplest form. And then number C, 25/75. Okay, 25/75. I divided it there by, I divided it by 5. You can divide it by 25. You still get the same answer. So 25 divided by 5 is 5, and 75 divided by 5 is 15. You can see the number is not in its simplest form because we can still divide it. So we further divided by 5/5, got 1/3.
Why are you telling us things we already know?
And the last one is 12/18 divided by 6/6. And then 12 divided by 6 gives us 2, and then 18 divided by 6 gives us 3. Okay, so you can also do this at home. I had someone saying they already know. Yes, remember, if you already know something, it doesn't mean that someone else knows it. And this is a recap of what you have done in grade 6, introducing you to grade 7 work. And then
hello.
You can do this at home. Okay, and then in summary, remember these points about comparing, ordering, and simplifying fractions. Only compare if the denominators are the same. If they are not the same, you make them the same first, and then there are many strategies you can use to keep the denominators the same. You have to choose the one that you know best. And then when simplifying fractions, you always divide with a number that divides both the numerator and the denominator. Remember, what you do on the numerator, we also do on the denominator. And then tomorrow we are going to look at improper fractions, mixed numbers, and equivalent fractions. These we're going to connect them with your addition and adding fractions, subtracting fractions. We're going to also multiply fractions. Then after to decimals. So until then, remember, it is about practicing. Practice more and you get it right. Thank you. I'm out.